Okay, class, welcome back. Today we're going to sort of conclude this portion of the book, section 4.3, and we're going to do so with talking about the applications of right triangle trigonometry. Now, before we jump into this, I want to draw a line, and hopefully you guys remember the class activity where I was having you guys measure the back wall. That's exactly what we're doing here. We're solving problems where you're basically measuring the height of things, and you know an angle, you know a side, maybe you know both sides, you're looking for the angle, something along those lines. Basically, you're using right triangles to figure out things like elevation and measure height. So to do so, imagine we've got this building right here, and there's a guy standing on a balcony. And he's got a line of sight, and there's an airplane up in the air. You guys are going to have to bear with my drawing abilities here, or lack thereof. So we've got an airplane up in the air, and say there's also like a little car on the ground right here. Now, I fully expect you guys to have all of this stuff drawn out much better than myself, right? So we've got a car, something like that. And if the important thing here, the important line is to remember that, we've got this horizontal line right here. This is the horizontal. This is if he was looking straight out of his balcony. Horizontal line. And then here we've got, if he looks up at the sky and he sees the plane, I'm going to draw another line right here. He sees the plane. Another line down here. He sees this car. So one is an angle of elevation. That's going to be this guy right here. Here we've got an angle of elevation. Elevation, of course, meaning up, right? So you're starting at one point and you're looking up, so it's going to be an angle of elevation. Now this one is going to be an angle of depression. So when a problem gives you an angle of elevation or an angle of depression, says an angle of elevation is 20 degrees, etc., then you know that then he's looking up. Whereas if it gives you an angle of depression, then you know that they're looking down. So let's go ahead and do an example problem. So here we've got a guy standing, he's looking at the top of a building. So here's our example. A guy is looking at the top of a building, and he is 5 feet tall, or at least where he's measuring from, so he's got his little scope here, is 5 feet off of the ground. So that's a really important measurement to know. Similar to when you guys were measuring the wall in the back, it was important to know that from where you were measuring. If you were measuring while you were just standing up straight, it was going to be somewhere around 5 feet. Say you were measuring down on the ground, then it was not going to be 5 feet. It's going to be 0 feet. Oops, sorry, I just realized I was off. It's going to be down on the ground. It's going to be 0 feet. But in this case, he's measuring, so we've got this horizontal line right here. Between the horizontal line and the ground, you know is going to be 5 feet. So you're going to take that into account at a later time. Okay, so here we've got the total height of the building is going to be h. And what he's measuring right here is not the total height of the building, but he's measuring a, which is the total height of the building short 5 feet because he's standing 5 feet, or the measurement is 5 feet off of the ground. So he's taking this measurement right here. He's got a line of sight to the top corner of the building. And this angle right here is 22 degrees. That's what he measures. Now I know it took a little bit of setting up to get this problem going, but it's basically just a simple problem, exactly like we were doing in class. So here we've got line of sight, 22 degrees. We're looking for something. We need one more measure. And sure enough, we do know that he is 300 feet away from the building when he's doing this measurement, 300 feet. So the guy starts at the building, he walks away 300 feet, he measures 22 degrees to the top. Remember, there's this 5 feet here. So basically, if I was to redraw this triangle that we're looking at right here, we've got 22 degrees, we've got 300 feet, and we're looking for A. Awesome, no problem. Super easy. This is just a TOA function, right? So I've got my opposite, I've got my adjacent, and I've got this angle. So I know that the tangent of 22 degrees is going to be equal to opposite, which in this case is an A, and 300 feet adjacent is going to be 300 feet. So now I can do some super quick algebra. 300 feet multiplied on both sides. And I just get that A is going to be equal to 300 times the tangent of 22 degrees. Now if you're plugging this in your calculator, always remember you've got degrees and radians. Make sure you're in the right units. So you find that the height of the building, or not the height, sorry, this measure right here, A is equal to 121 feet, about. So I'll do some squiggly equal signs right there. It's about 121 feet. Now what is the total height of the building? Remember, you can't forget that where he was measuring from was 5 feet off the ground. So if this is 121 feet, then this right here is going to be 5 feet. And so the whole thing is going to be, the height is going to be 121 feet plus 5 feet is going to be equal to about 126 feet. Bingo. Nothing to it. Now there's a lot of different problems you can use in order to do cool things, other cool problems using trigonometric functions and right triangles. Let's take a look at another example. Another awesome one is to measure the angle of elevation of the sun. Okay, so say instead of this one, so I'm going to give you some different information here. In this example, what we're looking at here is we've got a building. This is a very blocky building. And you've got the sun is going to be over here somewhere. Right? And we all know the sun, what does it do? Well, it casts shadows. And so we've got the shadow of this building right here. Sure enough, and so the sun is casting the shadow, and you're trying to figure out, say the shadow ends right there. I was trying to give it some 3D sort of look, but I failed. So we've got this shadow here, and I'm looking for, in this problem, I'm looking for this angle right here, theta. Looking for theta. So what I do know, in this case, I do know the height of the building is 21 meters. I also do know how long the shadow is. That's pretty easy to measure, so I can say this is 25 meters. Just like this. 21 meters high, 25 meters wide. And so you're asked to find the angle of elevation of the sun to the nearest degree. Okay? I'll put that down here. Find angle of elevation of sun to nearest degree. Okay, so in this case, I don't have an angle, but I do have, in this case, my opposite, which is going to be 21, and my adjacent, which is going to be 25. Super easy. I'm still using my TOA. So I know that the tangent of theta is going to be equal to 21 meters divided by, that's my opposite, divided by my 25 meters. So I'm also looking at 21, so I could just say 21 divided by 25. And so in order to plug this into your calculator, right, so you need to do the inverse tan function, or the arctan. So this is written as arctan of 21 divided by 5, or 25, is going to be equal to theta. It's also written, or on your calculator, it might be, the button might actually say tan to the minus 1. So usually it's like a shift tangent, tan to the minus 1 of 21 over 25. The exact same thing, either one, is going to be equal to theta, right? And so when you do this calculation in degrees, make sure you're in degrees, you find that theta, you put this in your calculator, theta is going to be about 40 degrees. So to the nearest degree. So the angle of elevation of the sun, figured that one out super quickly. Theta is just going to be equal to 40 degrees. Oops, I just realized I ran off the screen. So once again, so we've got the arctan, or tangent to the negative 1 power. That's how it's usually put in most calculators. So that's going to be the angle of elevation. We'll go from there. We'll practice many, many more of these applied problems, but that'll end this section of the book, and we'll have another review session, or a quick review session, and then to prep you guys for a quiz. All right, I'll see you guys in class tomorrow.